In this lesson, we are going to discuss digital signature, the nuts and bolts of digital signature. You might have heard about it 1,000 times. You might have used it 1,000,000 times without you even knowing. When you access your Facebook, Instagram, bank accounts, everywhere you are using your digital signatures. The SSL works on top of digital signatures. Now, if you have followed the hashing and if you have followed the RSA correctly, you will not find any difficulty in digital signatures. But in case you have any questions on the hashing and the RSA, feel free to refer back before taking up this chapter, because this chapter is based on the hashing we discussed before as well as the RSA. It's nothing but a combination of hashing and RSA, the digital signatures. Again, yet another super important topic. Without further introduction, let's get into it. So let's start with a recap of what we have learned so far. So we have the cryptography, which is the first pillar of the 2 pillars of security we've been discussing from the beginning of this training. So inside cryptography, we have discussed hashing, then we discussed encryption, and then the RSA. So both are encryptions, 2 different encryptions, both symmetric and asymmetric encryption. These 2 are encryptions. But for the sake of discussion and explaining things equally, I'll be always describing this as encryption and this as RSA, PKI, etc. because almost always they are used for drastically different purposes. Now these are the stuffs we are going to mix and match throughout the first pillar. The first mix and match we are going to do is RSA and hashing. So we're going to combine these 2 things right here and create something called digital signatures. So that's what we are going to discuss in this particular lesson, digital signature, in which RSA and hashing we are going to combine. So to get into the details of digital signature or signing a hash, we need to pay attention to the symmetric nature of public key encryption. So what we are interested here is mainly these 2 equations right here. So one is this, the message raised to E public exponent. We have seen this in the previous lesson. If you want to review it, feel free to go ahead. It's the exact same example we have seen in the previous lesson. And another equation right here, C raised to D mod N, as you can see here. These 2 equations. So M raised to E mod N and C raised to D mod N. So these are the equations which encrypts and decrypts. So this is for encryption and this is for decryption. As you can see, these are very symmetric, which means that with slight modification, I can interchange these keys. And what I can do is that I can encrypt using the private key and decrypt using the public key. Just reversing what we've been doing. Just the keys are getting reversed. Nothing else is getting reversed. How we are able to do that? Because of the symmetric nature of the equations. Instead of this E here, we'll be using D to encrypt, and vice versa, we will use E for decryption instead of D. So to get a proper example like before, I have given this particular prompt to search, or you can search in Wikipedia or somewhere to understand the digital signature algorithm, which is nothing but the keys are getting reversed. So we'll go through the same thing we have gone through in the last lesson. To P and Q, we are creating N, and then the Euler's Gaussian function, P minus 1 into Q minus 1. All the calculations remain the same. If you want, you can review. So coprime with Gaussian function, that is what is E. No change in calculating the private key exponent, which is the D. All of those things remains exactly same. So this is the public key and this is the private key. Everything is same. Now, what we are going to do here is we are having the message. The message is 123. The number is 123. That is the message we want to hash or message we want to sign. We'll talk about signatures a little bit later, but all we are going to do is going to create a hash. Hashing we have discussed before. It is just a representation of this particular number. So in this case, they are simply using that number itself as a representation of the number. That is quite possible. If your data you're representing is too small, like 123, you can use the same data as its representation. You don't need to perform any hashing. By that standard, a data itself is a hashing algorithm. Probably it's the best hashing algorithm with its own difficulties. Doesn't matter, our hash is also 123, the same data. Now, this is the symmetry part which I was discussing about. What we are doing, we are creating this particular calculation right here. 123 raised to the private key exponent, which is D in this case. 123 raised to 2753, which is the D we have calculated. And mod N, which is P into Q. And we get the encrypted text here. As you can see, we are using the private key for encryption. Remember, in the previous case, we use public key for encryption, but we have noticed the symmetry of the equations and we reversed. We are using private key for encryption. When we use private key for encryption, it is called a slightly different name, which I will discuss shortly, because we have not discussed what is a signature so far. I'm just running you through the math or trying to convince you that these equations you're seeing can be reversed, or the public key and private key can be reversed. That is the idea I'm trying to bring in here. So let's focus on that particular part and not the signature part alone. We'll discuss about the implications or the ramification of this particular artifact later throughout this lesson. But for the time being, the private key and the public key can be reversed in terms of encryption and decryption. Now let's see how it is getting decrypted. So let's forget all this part. I will explain all these things later. And the decryption part is this, just like before. This is the ciphertext, which is 2921 raised to 17 mod n equal to 123. So the only point which I'm trying to tell you is nothing about digital signature or anything like that. The private key and public key simply can be reversed. You can encrypt using the private key and decrypt using the public key, as well as you can encrypt using the public key, which we saw before, the lesson before, and decrypt using the private key. That is the only point we are trying to understand here. The reason why we are taking this in a two different way is the purpose of these two things are completely different. The first one is used for transferring messages. The second one, when you encrypt using private key, which is what you're seeing in the screen right now, is used for something called digital signature. So now that you are convinced that the private key and public key can be interchanged, as you're seeing in the screen right now, let's discuss the part what is a signature is all about. What do you mean by signature? So the name signature is all about proving that something is done by someone. Let's talk about my signature or my thumbprint or whatever is specific to me, which I can put it into a document. I'm talking about the normal physical signature. We are going to put it in a document. So I have a document here. So this is the document. It can be any document. It could be a rental agreement, a property document, account statement document signed by a bank, or anything like that. So let's see, this is an account statement. And it has to be signed by the bank manager to be accepted by certain organizations and entities. Now, what he's going to do, so I'm the bank manager. I'm going to put a signature here. So this is my signature. So I put a signature here. So what this is all about, there is a document. So there is this data right here. So this is the data. So the document has so much data inside it. Now I'm putting a mark onto that document. I'm putting a mark onto that document such that I have verified this particular document, and this particular mark is very specific to me. So this mark right here, or the seal, So there could be a seal as well. Let's put a seal. That's a seal in a different color. We'll put a blue seal. The seal of the bank. That's also part of the signature normally. So this is the seal of the bank, the document. Seal and signature normally we get. Account statement. So this is the account statement. Now what are the properties we are looking here? So we have a document which is a data. And what else we have? We have a seal plus signature. Those are the two things we are having right here. Now whoever has put the seal and signature has verified the integrity of this particular document right here. They have verified, they looked at the document and verified it. After that, they put the seal and signature. So this seal and signature, if someone like Eve, if Eve is able to put the seal and signature, there'll be no value for this seal and signature. Eve can make a document like this with this numbers changed. So this numbers Eve is modifying and replicating this seal and signature and putting it out there. Then there is no value for the seal and signature. So this seal and signature should not be duplicated. The seal and signature should not be duplicated by anyone other than the bank manager. In this case, it's me. So AG is the bank manager. And Eve cannot reproduce my signature and seal because it has its own complications. My signature is a complicated signature and it is very difficult to reproduce. Now what else is there? There is one more property we need for this whole thing. Someone should be able to verify that it is indeed my signature. So someone who is looking at the seal and signature should verify that indeed the seal and signature is from AG, who is a bank manager, and not from anyone else, like Eve, for example. So those are the hidden requirement of signatures. It should not be reproduced. It should make sure that it is connected to the document. For example, if this seal and signature is in some other document, this is where the seal and signature is standing. Will someone verify this document will allow you or respect you for the seal and signature in some other document? No. The seal and signature should be connected, not reproducible, connected and verified. It should not be reproducible by anyone else other than Mr. AG here, who is the actual signing authority. And it should be connected to the document. It should be inside the document. If it is somewhere else, it has no value. It should be connected to the document. And someone should be able to verify it without any doubt that this is the signature of AG and not Eve. So that is the signature is all about. Now, the question is, how can we achieve this exact same setup with all the encryption technique we have discussed? The digital signature. That's what we are going to discuss. So we'll keep this three things in mind: non-reproducibility, connection to the original document, and verifiability. And we'll come up with the mechanism. Now, again, starting with a document, in the case of digital, let's say it's a file, it's a PDF file or something like that. So we have a file here and we need to put a digital signature in this particular file, or we are going to create a digital signature. So the first thing we are going to do is to compute a hash of this file, a SHA-256 hash, right? So I'll tell you why we are creating a hash and not the document itself. Remember the previous case? The signature was only taking little space inside the document. It was not using the entire space. The signature and the seal was not using the entire space in the document. It was only using a little bit of space in the document. So which means that the whole thing was a connection to the document. That is what hashing is all about. We are trying to get a representation of this whole file. So remember the requirement of hashing we discussed before? It should uniquely represent the document. If there is a small change in this file, the hash will change. That is the single most important property of a cryptographic hashing function like SHA-256. Now what we are going to do with this hash, that we will discuss, but let's try to understand what hash is all about. Hash is the representation of this file. Another property of the hash is we cannot create a different file mathematically with the same hash. Now, if I make a small change in this document, the hash will change drastically. Also, we cannot make any other document with this particular hash. It is 100% unique that way. The hash is 100% unique. Now we got the hash of this file, which is a representation of the file. Now what we are going to do, we are going to encrypt that hash using our private key. So private key plus hash, and we'll use our equation, the RSA equation. We have seen that hash raised to d mod n. So that's the equation to do this encryption. Whatever value we are getting, we are going to attach that to the document. So this is the private key of Mr. AG. AG's private key. Let's put that in a different color. So this is AG right here, the actual signing guy, and he has his private key. So this is AG's private key, and the hash is of the file which AG is planning to sign, and AG is doing this particular equation. Hash raised to d mod n, and the result AG is attaching to this particular file right here as digital signature. So this is going to call digital signature. Now, how do we verify this? So what are the properties you are looking here? Let's write it down again. So one is connection to the document. The signature should be connected to the document. There's no point we having signature of some other document. It should be unique. If Eve is able to create the same thing right here, we are having problem. Only AG should be able to create. What is the last one? Verification. We need to have a mechanism to verify that it is not created by Eve, but it is created by AG. AG is the guy who is signing the document, not Eve. Remember, Eve can have this entire document, including this hash, including this signature. This whole thing is public. The only thing which is not public is the private key. Everything else is public. The private key is the only thing which is private to Mr. AG. Everything else you're seeing here in this page is public. Eve has access to it. Now, how do we do the verification? The verification is done using the same mechanism, using the public key of this corresponding private key. Remember, the public key and private key are pairs. Now, Bob is getting the document. Bob is the guy who is verifying the document, which is signed by AG. Bob need to make sure that it is signed by AG and not by Eve. What Bob has? Bob knows the public key of AG. Pub AG. Bob has this thing right here. Now what Bob will do? Bob will get this document along with the signature. Signature is there right here. Bob get this document along with the signature. Now Bob will compute the hash. Bob will compute the hash independently. Bob will compute the hash independently using SHA-256 algorithm. And that is hash 1, H1, let's say H1. Another thing Bob will do is Bob will take this signature right here. There's a signature which is obtained by this particular equation right here within the document. That signature is there. Bob will decrypt that signature using the equation signature SG raised to E mod N. So that is the equation Bob will be using because E is the public exponent along with N. And what Bob is going to check, this is hash 2. This is the calculated hash 2 from the signature. Bob will check if hash 1 equal to hash 2. Hash 1 equal to hash 2. This is what Bob checks. If it is equal, it means that the hash created by AG is exactly equal to the hash created by Bob. That means that the document is not tampered or document has not changed, and it is indeed verified by AG. Now let's consider the possibilities with Eve. So Eve has this document, right? So she has her own private key. The only thing she doesn't have is the private key of AG. Everything else Eve has. Now Eve has this document. She computed the hash. She got the same hash as AG. Now Eve is encrypting that hash just like AG did and signing it here and giving it to Bob. Now the only difference is instead of AG's private key, it is Eve's public key. Now what happens? Bob has the public key of only AG, not Eve. So when Bob tries this equation, it is going to fail because this particular number right here, this public exponent, and this is paired with AG's private key and not with Eve's public key. So the decryption will fail and the number we obtained as hash 2 will fail, and ultimately this check will fail. Then Bob will understand that, okay, this is not signed by AG. Something has happened. Someone has tampered with something. Someone has messed up with the document. I'm not going to trust this document. This is a fake document. Now, another possibility. Eve is again very smart. Another possibility, Eve knows all these things. She is taking the signature out. She knows that it is signed by AG. She knows that she cannot replicate it because she doesn't have AG's private key. So Eve, what she's going to do, she's going to take this signature out and keeping it with her. And she's going to change the document. She's going to add an additional entry to the document to fake the document. She changed the document and putting AG's signature into it. So the document has been modified, but signature, AG's signature is being put into the document. Now what happens? Bob gets the document. He computes hash 1. He computes the hash 1. That is the hash of the changed file by Eve. Eve has changed that file. That is a hash 1. Now Bob will take the signature. Signature has not been tampered. Signature is still the signature which AG has given. Now Bob will use the public key of AG. So this is the public key of AG and does this calculation right here. And he will obtain hash 2 successfully because it is the AG's public key and it is signed using AG's private key. So the hash 2 will get calculated. But the problem is the hash 1 and hash 2 will never be same because there is additional information in the file. The file has been modified. So the hash, cryptographic hash, will be modified as well. So this is the crux of digital signature. The signature is connected to the document because the hash is of the document. That is the connection, the hash and the document. If you modify the document, the hash changes. That's the connection part. It is unique because the digital signature can be created only with a private key of AG, and Bob can always verify it is created from the private key of the AG using the public key of AG and compare it with the hash of the file. So that is how digital signature work. Very important algorithm. It is used almost everywhere. Cryptocurrency, SSL, file integrity, everywhere. So if you have questions, feel free to ask. Also watch the video again. If you have confusion, watch the previous one. Also, if required, watch the hashing video, the lesson which we explains hashing as well. Maybe a little too much. Keep watching the video till it sinks into your brain. In fact, a lot of these concepts, if you're hearing for the first time, it's quite natural that you may not feel comfortable. So always repeat or even refer to other trainings and materials and things like that if required. I always recommend such kind of extra readings and things like that. Now let's see an example, real world example of all these things. So far we've been discussing the concept. As always, we are going to do this using OpenSSL. So as usual, let's create a document which we want to create the signature. digital signature of the document. So Notepad, any document, any file should be fine if you want to do this. I'm just creating a new file, doc to be signed .txt. It can be any file, including binary file, text file, anything will work. It's about just signing the document. This is a document to be signed by AG. So this is the document. This has important info which cannot be tampered. So this is the document which we have created. Now what we need of course private key to sign the document. To create the private key, we have seen the command already, gen RSA. So that's the command, OpenSSL gen RSA. Then the key length, that's the command. Actually, the command is right here from the previous session, but I'm going to type it anyway. OpenSSL gen RSA out private key for signing .pem. And this time probably I'll go for 2048 2K size key. So the key has created. Let's have a look. Notepad, private key for signing, and the key has been created. Looks good to me. And now we need to create the public key to verify corresponding to this particular key. Again, the command is on the top. So this is the command, OpenSSL RSA in private key.pem out public key out format pem. So that's the command we are going to execute. OpenSSL RSA in private key out public key for verification .pem, then output format out form PEM -- pub out. So here it is 2 hyphens, the other ones are just 1 hyphen. It's all just how the command is. Let's have a look at the public key. Notepad public key for signing. So we have the public key here. So this is the public key for verification. Now we need to sign the file or create the signature for the file. So the command is OpenSSL DGST. It's all in the documentation of OpenSSL DGST -sign, then the private key -out the signature, and finally the file name which we need to find the signature about, which is doc. So let's see the command. Let's review the command before we execute. OpenSSL DGST. DGST stands for digest. It is another name for signature. I have seen a lot of official documents uses digest. Sign, then the private key, and out signature. So signature will be in this particular file, and then the file which we need to sign. So one more argument we can pass here is the algorithm to use the signature, SHA-256. By default it will take, but it's always good to specify that. Right now I'm going to use SHA-256 for the hash calculation. We have discussed that. Let's see what is inside the file created. Notepad signature.txt, and as you can see the signature is pretty garbled. It's a binary file. It's not a PEM file or anything like that. We have seen this format before. It's a binary file. It's not a text file. That's why it is showing like this. Make sure that you don't save it in Notepad or anything like that. You will not get the same file. The file get modified and destroyed. So never save it in case if you're opening this in Notepad. But the signature has been created. So verification is very similar to the previous command which created the signature. So here it is verify instead of sign, and here it is the public key, and then in signature, and finally the doc. So let's see the command. Very similar to the previous command which we have executed. OpenSSL DGST, then SHA-256, then verify instead of sign, then public key instead of private key. We passed private key for signing, public key for verification, in signature. So input is signature.txt and doc to be signed. Let's see what we are getting. I made a mistake, so I need to change this to signature. In is not the way to give signature. It is signature. Yeah, that worked. So only one mistake I made, which is in signature. It is signature actually. So this is the correct command in case if you want to note down. So it was giving an error right here, and this is the command to verify. So verified, okay. So one of the things I would like to give is give another private key and see if it is able to verify with a different public key. So what I'm going to do is I'm going to execute this particular command again, and I'm going to give it 1 here. So OpenSSL gen RSA. So this is underscore Eve. So I'm the Eve. I have my own private key. I have generated that, and I'm going to generate the public key as well, just to see if this can be verified using a different public key. Here also I'm going to mention 1 underscore Eve, 1 underscore Eve. Everything else remains the same. And in the last command, we are going to perform using 1 underscore Eve. So everything remains the same, only the public key and private key is not paired. That's what this is about. What's going to happen? We got verification failure. As you can see here, verification failure. Now let's see the success again. Let's see the success again. So this is the successful verification with the correct private key. Verified, okay. Now what I'm going to do is that I'm going to use the same signature and the public key, but I'm going to modify the file. So notepad, doc, and I'm going to add a small change. Just going to put a 1 in the end. So Eve has put a small change in the file, and I'm going to save it. I'm going to try to verify it again. So this is the verification command which was successful before. As you can see, again verification failed. So signature is not matching. As you can see, slightly different error for different issues, but verification is failing in both cases. Now if you want, you can try a different signature with a different private key, but you should get the exact same error as you are getting here. But ultimately, that is what digital signature is all about, and it is used almost everywhere as we know it today. Very important algorithm, very important security artifact in the modern world. So we have seen digital signatures, how we are signing a document, code, normal document, anything. We have seen how hashing as well as RSA is used for digital signatures. We have seen some examples as well in OpenSSL. Feel free to try out some of these things and read more about it, because we are going to see that in all over the place rest of the training, digital signatures. Feel free to ask any questions if you have. Take your breaks. All the basics is needed for this kind of complicated topics. I know I'm repeating, but that's how it is. Thank you, and see you in the next lesson.